This is Project 5, video number 2, the one in which we coded up. Here's the code outline. I'm going to switch over to the editor. Go function, no return, equals, I'm going to call it plot tension, and it takes no arguments. End that function, tab over. And let's see what we had in mind here. Initialize some variables, m, g, l, and h. M equals g, l, h equals m is was 112 grams, so 0.112 kilograms. G is 9.8 meters per second squared. L is 1 meter. I go 1.0. H is 0.5 meters. And you don't need this space, but I choose to put it there. Okay. Now what? X equals linspace, and then ft equals X equals linspace from 0.01 meters to 1 meters in 100 steps. And Ft, the tension force, force of tension equals 0.5 times m times g times l times the square root of 1 dot slash x dot to the power of 2 plus 1 slash h to the 2 semicolon. And you know what, I think I'm gonna play around here. I go from 0.25 to 1 with only 3 values, 4 values. 0.25, 0.5, 0.75, and 1. Alright. And so I'll leave that off and see if that calculates it. For now, I gotta fix it up later. I'm going to put the plot command in though. I think it's gonna work. So x comma ft. I'm gonna save that as plot tension.m, and I want to save it in projects. Okay, and then try to run it. So MATLAB, I gotta make sure I'm in the same place there. This is fall 2013, 131 projects. Project 5, my code. Alright. Plot tension. It takes no arguments, so I don't really need the parentheses. And I'm getting a graph that looks like this. So it's saying the farther the support point is out on the rod, the smaller the tension. That makes sense. Let's get a bigger moment arm the farther out it is. Drops fast at first and then more gradually. Okay, and FT, I get those values. 1.3192 at that would be at 0.75 because I went 0.25, 0.5, 0.75. So 1.3192, and for my test case, that is our test case. Here's my test case. 1.3192. So that would round to 2, round up to 2. So that's looking perfect. 1.3192, 1.3192. So I think it's working. So I got to clean it up a little bit. Well, I got to clean it up a lot. But we'll do that in the next video. I got to make it right, make it so it's doing what it's supposed to do. 0.01 to 1. I'll take 100 steps. I'll not print that out to the screen. Put that semicolon there so it doesn't print anything to the screen that's not supposed to be printed to the screen. I had it printed to the screen for testing, but now I got to get rid of it. Plot tension. Take a look at the graph, and it's kind of cool. So starts out really high. In fact, the reason we didn't go from 0 centimeters or 0 meters to 1 meter is it goes to infinity in the limit as our connection point goes to 0. It would have no momentum if we went all the way there, so the string couldn't hold it up. It would flop over. The ruler would, but it gets bigger and bigger as we go close. But drops off, and then once we get in here to set point about 10 centimeters, doesn't really change much after that. So it drops like from 55 rather quickly to 10 newtons to hold it up, 10 newtons a string, and then after that it drops much more slowly. Okay. Take one more look at this. Yeah, I think we've got it coded up. That's no return. Oh, I know. Nothing. Call it nothing this time. There's nothing to return. So, since I've been messing around with it, I better make sure it still works. Run it one more time. Yep, it gives me the same graph. And go back, make sure it is indeed saved. Yep. Okay, so I'll call that a wrap for project 5, video number 2.